Take a moment and look up at the night sky. What you see feels ancient, and it is, but what you don't see is far more unsettling. There are regions of the universe that exist. We know they exist, and they will never be observed. Not by us, not by our descendants, not by any future civilization, no matter how advanced. This is not pessimism, it is physics. When we talk about seeing the universe, we usually imagine distance, but astronomy is not the science of distance. It is the science of delay. Light does not arrive instantly. It travels, and even though it is the fastest thing we know, it still needs time. When you look at the sun, you see it as it was just over 8 minutes ago. That is how long its light takes to reach Earth. A simple but unsettling fact is this: if the sun were to vanish right now, gravity included, we would not notice for more than 8 minutes. We would keep orbiting. The sky would look exactly the same. Only when the last photons arrived would reality finally update. Now, stretch that delay. Stars you see tonight are years old. Some galaxies appear as they were millions of years ago, and the most distant objects we can observe are seen as they were more than 13 billion years in the past. That means something profound. We do not see the universe as it is, we see it as it was, and even that view has a limit. Astronomers call it the observable universe. The phrase sounds expansive, but it hides a restriction. The observable universe is not everything that exists. It is everything whose light has had enough time to reach us since the beginning of cosmic history. That is all. Beyond that boundary, light still travels, stars still burn, galaxies still evolve, but their messages are forever in transit. Because the universe has a finite age, and light has only had a finite amount of time to move, right now, the observable universe measures roughly 93 billion light-years across, not because light traveled that far, but because space itself expanded while the light was on its way. A lesser-known fact is that even if the universe stopped expanding today, the observable universe would still never grow fast enough to reveal everything. Time has already run out. And here is where it becomes stranger. The edge of the observable universe is not an edge of matter, it is an edge of information. If you could somehow travel outward indefinitely, you would not hit a wall, you would not see a boundary. You would simply pass a point beyond which nothing that happens can ever influence you. No signal, no photon, no cause and effect. That boundary exists right now, and it is not negotiable. The idea that space itself can expand is not intuitive. We are used to thinking of objects moving through space, like bullets or drifting ships. But on the largest scales, galaxies are not racing away from us through a static universe. The universe itself is stretching, and everything embedded in it is carried along. A useful way to imagine this is not an explosion, but a surface. Imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot, even though none of them are moving across the surface. The space between them is what grows. Our universe behaves in much the same way, just in 3 dimensions instead of 2. Now here is the critical consequence of that expansion. The farther away a galaxy is, the faster it appears to recede from us, not because it is speeding up through space, but because there is more expanding space between us and it. At a certain distance, that recession becomes extreme, so extreme that even light cannot overcome it. This is the cosmic horizon. It is the boundary beyond which light emitted today will never reach us, no matter how long we wait. Not in 1 billion years, not in 1 trillion. The expansion of space increases the distance faster than the light can cross it. The light is not slowing down. Space is pulling away faster than it can compensate. This is not a hypothetical scenario. It is happening right now. There are galaxies whose light we can still see because it was emitted billions of years ago when they were closer. But any light they emit today is already lost to us forever. Their future is causally disconnected from our own. A striking fact is that many of the galaxies visible in deep field telescope images are already beyond this horizon. We see them frozen in their ancient past, but we will never see them age. We will never observe their stars die, their galaxies merge, or their structures evolve. They are permanently stuck in cosmic memory. If this idea is starting to settle in, take a second to subscribe and like the video. Not as a distraction, but because this is one of those rare topics where understanding really compounds, and staying connected helps you explore deeper layers like this together. Now, let's push this further, because the horizon is not static either. As the universe continues to expand, the cosmic horizon slowly shrinks in terms of what remains accessible. Over immense timescales, fewer and fewer galaxies will remain visible. Eventually, distant galaxies will fade beyond detection entirely, not because they stop shining, but because their light is stretched so severely that it becomes undetectable. In the far future, an observer in our galaxy would see a universe that appears almost empty. No distant galaxies, no evidence of expansion, just a lone island of stars surrounded by darkness. Without careful records, that observer might even conclude that the universe is static and small, unaware that an immense cosmos lies forever beyond reach. This leads to a quiet but powerful realization. The universe is not only vast, it is actively hiding itself from us over time, not maliciously, not mysteriously, simply as a consequence of its own dynamics. And that brings us to the most unsettling part of all, because the cosmic horizon does not mean there is nothing beyond it. It means there is something there that we can never measure, never confirm, and never directly observe. We know it exists, but we will never see it. Once we accept the cosmic horizon, a new question becomes unavoidable. If light from beyond that boundary can never reach us, how do we know there is anything there at all? Why are cosmologists so confident that the universe does not simply end at what we can observe? The answer is subtle but solid. It comes from patterns. When astronomers map the observable universe, they do not see matter piling up near the edge. There is no thinning, no sign of a boundary. Galaxies near the observational limit look statistically similar to galaxies closer to us. Their distribution is smooth. Their large-scale structure is consistent. The universe does not behave like a bubble with a wall. It behaves like a small sample taken from something much larger. There is also the cosmic microwave background, the faint afterglow of the early universe. This radiation is remarkably uniform in every direction. The tiny fluctuations it contains are measured to 1 part in 100,000,